Okay, so the previous video we went over the general steps of translation. But you saw that they were putting very specific amino acids in certain spots. So it turns out every 3 letters will bring a particular amino acid. And for that you need to look at figure 1110. So if in the mRNA we have 3 letters that make up our codon, so let's say we have the letters ACA, then there will be an anticodon that will bring over a particular amino acid. So if you look in figure 1110, you can see that they have first, second, and third in that diagram. You have first base on the left, second base on top, third base over to the left. So in order to read this chart, if this is in the mRNA, then we will look in the chart in that first row. So you can see you have the rows U, C, A, and G. So we're going to look in the row that begins with A. We're going to then match that with the column that is C, because that is our second nucleotide. So in this box, we have row A and row C. And these two are going to intersect. And they have the 4 codons that begin with AC. And you can see that ACA is going to be bringing over the amino acid threonine. Now we don't need to, so there will be an tRNA that's going to be specifically bringing over the amino acid threonine. Now you don't have to memorize this table. I will give this to you on the test, but you do need to know how to use it. So when you have A, you look over here for the A. You find that row. You find the column C, and you find the box where those two meet. And in that box, you will see the code ACA, and actually you can see everything in that box is going to code for the amino acid threonine. This is what we call redundancy. So if I were to give you a set of codons in a mature mRNA, so let's say we have here mature mRNA, and let's say we have these letters. So remember, I'm not going to worry about diagramming the mRNA. Just like we did in the previous practice, we're just going to write a bunch of letters. So, and we'll write them in sets of 3 so that we know that what the codons are. Oops. All right. So, this is our first codon. And this is the first, second, and third base of that codon. So, if this is a mature mRNA, the question is, what amino acid would be in the polypeptide or protein? Remember, these terms are synonymous. So we're going to look at that table. We're going to go to the bottom row, which is G. We're going to then go to the column U, which happens to be the very first box on the bottom left. And GUA is going to code for the amino acid valine. So you don't have to, like I say, you don't have to memorize this chart, and you don't need to know the entire name. You just need to know that this codon is going to bring over this amino acid. Let's go to the next one. So this is the second codon. This is the first, second, and third spots here. So we're going to go to row A and column C where they intersect. And in that we see that ACU is going to code for that threonine again. This is representing the peptide bond that holds amino acids together. So now we can go to the third codon. First, second, and third spaces. So we're going to go to row C, and where it intersects column C, and we see that CCG is going to code for proline. So we just put PRO. Then we go to the fourth codon. First, second, and third. So we're going to find row U and column C. Row U, column C, we see that UCG is going to code for serine. And then we go to our fifth codon. And we keep going until either we do them all or we hit a stop codon. And I don't think we're going to hit a stop codon this time because I just picked some random letters. But we're going to go to row A and column C where they intersect. And once again, we'll get ACC. It's going to also code for threonine. So you can see there's more than one way. We only have 20 amino acids, but there are 64 ways you can combine these 4 letters in 3 positions. So part of today's thing is going to be translation and actually using this chart to show how you go from the mature mRNA to the actual protein. So let's do another one, and this time we'll have a stop codon in it so that you can see how that works. But otherwise, I'm just going to be picking random letters on an exam. It may or may not have a stop codon. I just pick bunches of letters. You just have to be able to translate what's particularly there. So let's say this time the letters we have are CAU, GGG, ACU, UAA, CCA. So we will do it the same way as we did before. If this is the mature mRNA, what would be the polypeptide that this would then translate into? So CAU, we'll find the row C and the column A. So row C, column A, we see CAU codes for histidine. So we'll put down HIS. So CAU will become the amino acid histidine. GGG, we're going to go where the row G and the column G intersect, and we see that GGG codes for glycine. So GGG will translate into the amino acid glycine. ACU will go to row A meets column C. We get threonine again. Sometimes my mind gets on a particular track and that's all it does. And then UAA, we're going to go to row U meets column A, and we see that UAA says stop. So this is a stop codon. So no amino acid falls in this spot. This is the end of this particular polypeptide. This one just happens to have 3 amino acids, but you notice there's still more code, right? We do not translate that because this said to stop. So once you stop, you are done. This is the end of the polypeptide.